Hello and welcome to our video on graphs of logarithmic functions. First of all, I have here a table of values for y equals log 10x, and I've already filled it in for you. You'll be pleased to know you don't need to bother doing that. I've just put them correct to 2 decimal places. So we've got a small value of x, then 1, 2, 3, 4, 5, and the values of y equals log 10x already organized for you. If we graph that, we end up with this graph here, which is this one. So I just want you to look at this one for now. And the second one is y equals 10 to the x. The second function we're looking at. So the yellow one is log 10x and the orange one is y equals 10 to the x. When you have a quick look at them, you can see that they're both exponential functions. They increase exponentially, as we talked about. You should be familiar with this one. This is a new one we're looking at, y equals log 10x. For this yellow one, y equals log 10x, the domain is real positive numbers and the range is real numbers. For the orange one, make this one orange. For the orange one, the domain is the x values, which is going to be real numbers, and the range is the y values, and that's real positive. I also want to point out in our graph here, I'm going to put it in green, is our asymptote for, actually I might just highlight it in green. Asymptote for y equals log 10x is x equals 0, and our asymptote for the other one is y equals 0. Should already know this one. This one is new, so it's just a vertical asymptote there. For y equals 10 to the x, I want you to interchange x and y and simplify the resulting equation. You can pause the video now to have a go at doing that yourself. Okay, hopefully you've had a go at doing this. This is what I get. First thing, swap the x's and the y's. So instead of y, I write x equals 10 to the Sorry about that glitch. I'm going to have a go at doing it the bottom half here. Swap the x's and the y's. X equals 10 to the y. We can then simplify this and take log 10 of both sides. And we get, this will stay the same, log 10 of x equals, these two will cancel, we're left with y. Y equals log 10 of x. I want you to think back to where you might have seen this before, swapping over the x's and the y's. And hopefully you remember doing this when we looked at inverse functions. So on the basis of this, we found that the inverse of y equals 10 to the x is y equals log 10 of x, meaning these two graphs are inverses of each other. So we can conclude that y equals, having a glitchy day today. Okay, I filled it in for you now. Y equals log 10x is the inverse of y equals 10 to the x, which would mean that our graphs should be reflected about the line y equals x. Now, I have drawn in this line for you here. Might not come up on your printout, but it is there. That's why we've got y equals x written. And you can see that these two are mirror reflections of each other about the line y equals x. So that is correct that they are inverses of each other. I want to have a look now at sketching some graphs. And the ones I'd like you to try are the ones I've highlighted here. E, F, G, and I. They're the main ones that we will need to know for this unit of work. And they're the main ones that I want you to focus on that I can talk about in this video. So you might like to pause and have a go at drawing those graphs based on what we did on the previous page. Otherwise you can continue to listen to see the worked solution. Okay, hopefully you've had a minute to have a look at the worked solution. Of course the solutions are down here, but I just want to talk them through for you. So starting with example E, I've rewritten the question here, y equals negative log 10 of x. And what you notice here is that this is the original graph that we drew on the previous page, y equals log 10x. What the negative out the front here does is reflects it about the x-axis. So it's just flipped over the other side of this x-axis. I've put down here r equals reflect. I just didn't have room to write it in. So this is a reflection when your negative is out the front. Question F, here's the question written out again, and the negative this time is directly in front of the x. And when we have the negative here, we end up with a reflection in the y-axis. So it reflects about this line from the original. Question G has this problem here, and there's a two-parter for this one. First one I want to point out is that the base 2 down here will make the graph, when you draw it, it shouldn't be as steep as the ones you've been drawing for log 10 of x. So smaller number means not as steep, higher number will mean more steep, for the base that is. Hard to show though on a graph, so not terribly important, but you just need to know it in case you need to draw two on the same axis, and that's how you would show a difference. What we are focusing on is that x minus 1 is in brackets, so the whole x minus 1 is to the log 2 of all of x minus 1, which means that the graph will be translated 1 unit to the right hand side because we've got a negative in there, so it will move this way. If it was x plus 1, it would move to the left hand side, so it moves up and down the x-axis. The last one I want to talk about is question I, which is written out here for you again, y equals log 3 of x plus 1. This one, and you can see where the brackets are really important here. There's no brackets here, so it's just log 3 of x, and the plus 1 is on the end. When the plus 1 is on the end, like all our other graphs that we've already looked at, all we're doing is moving the graph vertically up and down the y-axis. So I've written here, translated 1 unit vertically. You should be able to have a go at graphing, drawing your own graphs now. The other section that I want you to make sure you complete is question 2, which is about finding the inverses. And remember, all you need to do is swap over your x and your y, and then use your log laws and your index laws to simplify, and you should find that it will work out. Answers are at the bottom of the page. I've highlighted them for you. Thank you for watching this video.